So what I'm going to talk about are what are called measures of center. And a way of thinking of this, these measures of center, we're sort of looking for a way of balancing the data. So if we have our data, and it's sort of our distributions doing something like this, we might be looking for sort of a fulcrum point where we can balance our data. So we can balance on a point. That's kind of what we're thinking of. And we're going to look at different ways of, well, considering a measure of center. And we're going to take a look at, well, first off, is the mean. So we talk about mean x bar, and we represent mean with x bar. And this is where it's the sum of data values divided by the number of data values. So the sum of data values divided by the number of data values. So as an example, let's say we have this. Let's say our data is 1, 2, 3, 4, and 5. Those are our data values. Excuse me. So we have, well, first off, 5 values. So to come up with the mean, we add them up. And then we divide by, well, the number of values. Now, let me get a calculator here. Let's see. So we'll get 6, 10, well, 15. We get 15 over 5. And so the average is 3. So that's how we calculate a mean. Now, there's some properties of the mean that we want to be aware of. And first off, when we use the mean, all the data is used. So that's first, all data is used. Second, it's very sensitive to what we call extreme values or outliers. So let me give an example. So let's take our data set and let's change just one of the data points. We have 1, 2, 3, 4, and let's go with 5,000. So 4 of the values, they're kind of the same magnitude. They're the same magnitude. This one's way off, but it's only one value, 1 out of the 5. But if we compute the average or the mean, well, let's see here, 10, 5,010 over 5. Let's see what that comes out to. Comes out to 1,002. So the average value is 1,002. So even though only one value has this higher order of magnitude, it has an enormous impact on the mean. Excuse me. So when this happens, when you have something like this that's affected by an extreme value, we say that it's not resistant. All right. So that's the idea of the mean. Now, the other one we're going to look at is the median. So the median, well, it depends on how many values you have. But if you have an odd number of data, well, then the median is the middle value. Now, I need to make a point here. This is very important, is we need to make sure the data is in numerical order. This should actually be first. The data needs to be in numerical order. Now, once we've got it in numerical order, then we look for the middle value if we have an odd number of data values. Now, if there's an even number, we average the two middle values. We average the two middle values. So let me do some examples. So let's say we have this. So let's say this is our data. Well, first off, we've got to put it in numerical order. And now we look for the median. So the median, this is an odd number because there are 5 values. And the number 5 is, of course, odd. So that means to find the median, we just take the middle value. So x tilde equals 3. And that's your answer. Now, let's take a look at another data set. Excuse me. Now let's say this is our data. Now, if you look at this, there are 6 values, and 6 is an even number. So what we're going to do is put the data in order. One, 2, 4, 7, 8, 10. And because there's an even number, there's no exact middle value. So we're going to take the 2 middle values and average those. So 4 plus 7, excuse me, over 2, 11 over 2, or 5.5. And so 5.5 is going to be your median. All right. So that's the median. Excuse me. So mode. Now, mode is the most frequent data value. And there's different outcomes you can get. So, but we'll take a look at this. Let's see, we have, say, this. Let's say these are data values. So the most frequent one are the 3s. So in this case, the mode equals 3. Now, you can have more than one mode. So let's say we have this. Well, here, the 1s and the 4s are most frequent. So here we have 2 modes. The 1 and the 4. So we call this bimodal. And we could have more than 2 modes. That is possible. And we call that multimodal. That's another possibility. So some properties with the mode. Oh, and I forgot to mention properties with the median. Let me do that. Now, median and mode. Let me go back to median. And in a way, they go together if we talk about resistance to a point. With median, you're going to see resistance to extreme values. Mode, you could have resistance to extreme values provided, well, I guess the extreme value is not the mode. Like you could think of a situation where you have these numbers that are generally from 1 to 10, and there's maybe a couple 3s, 3 4s, a couple 5s, and then you have, say, 4 thousands or something like that. So, you know, there's some, in that sense, your mode would seem to be an extreme value. So now median here is resistant. It's resistant to extreme values, and here's why. If we have 1, 2, and 3, recall the median is the middle value. So the median is going to be 2. That's your x tilde. If we change 3 to 3 million, the middle value is still 2. So median is resistant to an extreme value. Let's see. Also with the mean, and the reason it is resistant is it doesn't rely on all values of data. This is unlike the mean. The mean, you had to add up all the values of data and then divide by the number of values. Here, we don't use this. We don't use this except for, well, locating the middle. So it doesn't rely on all the values of data. So there you go. That's why the median is resistant. All right. Now with the mode, get some properties for mode. Mode isn't just something you can use for quantitative data. You can also use it for qualitative data. And this will come up. For example, what's the most common grade on a quiz? What's the most common paint job for a car? These are all modes that we're talking about. All right. So another one that's used is called the mid-range. And we're going to return to an idea called range, which is not a measure of center. It's a measure of spread or variety. So, but we'll introduce it. Range, and again, this is not a measure of center. It's the max data value minus the minimum data value. And so that's our range. And so we define mid-range a little different though. It's going to be, instead of a difference, it's going to be a sum. And then divide by 2. In other words, it's the average of the maximum value and the minimum value. So for example, here's our data. So we need to figure out our minimum value and our maximum value. The minimum value is going to be 1. The maximum value is going to be 10. Let's see if I have a stronger marker there. And so what we're going to do is take those two values and average them together. There we go. So for the mid-range, it'll be 1 plus 10 divided by 2, or 11 divided by 2, or 5.5. And that's your mid-range. Now, there are some suggestions for rounding, and maybe a little stronger than suggestions. You might call them rounding rules. So first off, for mean, median, and mid-range. What we do here is when we round, we want to go one more decimal place beyond the decimal places we see in the original data. For mode, we don't round. So for mean, median, and mid-range, we go 1 decimal place beyond what we see in our data. So if we've got like data that's going to be to the 10th place, then for mean, median, and mid-range, well, for these, we'll round to the hundredths. This is the tenths. We're going to round to the hundredths. And then that's going to be it. Now, there's some special measures of center here, and I'll go over these. The first one is, let's see here. It's the frequency distribution. We want the mean of a frequency distribution. So the way this works is what we're going to do. Now here's F2 for this second bar. This is bar 1, bar 2, and bar 3. And there we go. So what we're going to do is this. If we want to come up with an average or a mean for basically a histogram, this is what we're going to do. We'll take the frequencies and multiply them to the class midpoint. Now, when we talked about constructing histograms, we talked about constructing them from frequency tables. So you don't necessarily need to actually convert your frequency table to a histogram. You can read the frequencies off the table. But we did construct what we call class centers. Remember, we had these things like class limits, and then on the outside of the class limits were the class boundaries. They were sort of the middle points of the gaps between actual classes. So class limits, class boundaries, and then we had a class center in the middle of each of these bars. So we're using that class center, we're putting it to work. We multiply the class center for a class to the frequency of that class. And we do that for all of these classes. And then we divide this by the sum of the frequencies. So this is how we calculate the mean for a frequency table or a histogram. So let me do an example here. So let's say those are our class centers. And let's say this frequency is 2. Let's say this frequency for this one. Let's call that, I think, a little higher. We'll call that 4. And we'll call this one 5. So these are our frequencies. So to come up with the mean frequency, the mean for the frequency distribution, we take the class center. So this is the first class. as a frequency of 2 times the center of 50. For the next class as a frequency of 5 times the center of 100. And then for this last one, we've got frequency of 4 times 150. And we divide by the sum of frequencies. 2 plus 4 plus 5. So we'll get 100 plus 500 plus 600 over 11, or 1200 over 11. And that's going to come out to, let's see, about 109.1. Round it to the 10th spot. So that puts us sort of right about here. This would be kind of like 109. If you kind of think of this as a balance point, it kind of makes sense. You got a heavier block here than over here. So it's about 109.1 or 109. So that's how we do a mean frequency, a mean for a frequency distribution. The last one we're going to look at is the weighted mean. In the way we do this one, we're going to have different weights. So we have our data value. Let's say we have this. Our data is x1, x2, and x3. And we'll do a numerical example. But this one has a weight. This one has a weight. And this one has a weight. You can kind of think of weights like frequencies. And so this is going to be similar to what we're doing with the mean for the frequency distribution. Instead of frequencies, we're going to be using weights. So it's going to be W1 times X1 plus W2 times X2 plus W3 times X3. And then we divide by, instead of the sum of frequencies, the sum of the weights. So essentially what a weight is, and you can think of it in a ways as like a frequency, but let me give you an example that we don't think of this as frequency, but it's something you've probably worked with before, and that's calculating a GPA. So let's say you have 3 classes. You have stats, bio, and English. Now, stats, you get an A. Bio, you get an A. English is hard. You get a C. I mean, it's hard class. So these are the grades. And let's say the stats class is 4 units. Bio is 5 units. Let's say English is 3 units. Now, what's going to happen here is this. These are our data. The grades are the data, but the units are the weights. So there's more A than there is C. If we just look at bio and English, there's more A. There's 5 units of A versus 3 units of C. So bio has a bigger weight than C does. So bio will have a bigger impact than English will. So the A will have a bigger impact than C. So what we need to do, though, is convert this to numerical data. And we've talked about this before. You can have what's categorical data, and we can turn it into numerical data. So, well, let's do this. But let's see. I should say ordinal data, and we can convert it into numerical. Now, A is 4, B is 3, C is 2. D is a value of 1, and F has a value of 0. So what we're going to do, instead of saying AAC, we're going to go 4, 4, 2. So our data is 4, 4, and 2. And this has a weight from stats. The weight is 4 units. Weight is 5 units. And the weight here is 3 units. So what we'll do, take 4 units, the weight, times 4, plus 5 units, times 4, plus 3 units, times 2, and we add up the weights. 4 units, 5 units, plus 3 units. So what we'll get is 16, 20, 6, over 4 or 5, it's going to be 12. Or let's see, that gives us 3642 divided by 12. And let's see what this GPA is. And it comes out to 3.5. And that's it. So those are your weighted grades or your weighted mean. And again, we're just looking at measures of center, trying to sort of get an idea where the data seems to be gathering. So that's it. If you have any questions, let me know.